In this lesson, we'll take a look at integration by parts. Integration by parts is used to find the integral of a product. The integration by parts formula reads, the integral of u times dv, that's equal to u times v minus the integral of v du. We must choose one factor, set that equal to u, and differentiate. We must take the other factor, set that equal to v, and integrate. And then we can substitute in the formula. So let's take a look at a couple of examples. First, we'll integrate 5x times the sine of x dx. Here we want to integrate a product. We have 5x times the sine of x dx. We must take one factor, set that equal to u. We must take the other factor, set that equal to dv. We'll differentiate the u substitution equation and we'll integrate the dv substitution equation. In figuring out which factor you set equal to u and which factor you set equal to v, the factor that you set equal to u, you should be able to differentiate that to 0 if possible. So in this example, I'll set u equal to 5x. I'll set dv equal to the sine of x dx. I'll differentiate the u substitution equation. We'll differentiate both sides with respect to x. For our left-hand side, du is equal to dx, and the derivative of 5x is 5. Since I need du in the integration by parts formula, I will solve this equation for du, so I'll multiply both sides by dx. So du is equal to 5 dx. Now I'll take the dv substitution equation and we'll integrate both sides. When we integrate dv, we get v. When we integrate sine x, we get negative cosine x. And now we'll substitute everything into the integration by parts formula. So the integration by parts formula says that we have u times v. So that's negative 5x times cosine x minus the integral of v times du. So we have negative 5 cosine x dx. So now I'll pull negative 5 in front of the integral operator. And the integral for cosine is sine. So our final result is negative 5x times cosine x plus 5 sine x plus the arbitrary constant c. Let's take a look at another example. Here we're asked to integrate x squared times e to the 2x dx. Sometimes you must use the integration by parts formula more than once, as we'll see in this example. Here we'll set u equal to x squared, and we'll set dv equal to e to the 2x. We'll differentiate u equal to x squared, so we have du is equal to 2x dx. We'll integrate the dv substitution equation, so v is equal to 1/2 e to the 2x. We'll now substitute into the integration by parts formula, which is u times v. So we have 1/2 times x squared times e to the 2x minus the integral of v du So we have x times e to the 2x dx. Notice that we have another product in which we must take the integration. So we must use integration by parts once again. So I'll set u equal to x. We'll set dv equal to e to the 2x. Here we'll find the derivative. So we have du is equal to dx. Here we'll integrate both sides, so v is equal to 1/2 e to the 2x. So now we'll substitute into the integration by parts formula. So we have 1/2 x squared e to the 2x minus u times v. So that's 1/2 x times e to the 2x. Minus the integral of v times du. So that's 1/2 e to the 2x dx. So now I'll distribute my negative sign. And I'll pull 1/2 in front of the integral operator. And I'll integrate e to the 2x, which once again will give us 1/2 e to the 2x, for a final result of 1/2 x squared e to the 2x minus 1/2 x e to the 2x plus 1/4 e to the 2x plus our arbitrary constant. Next, we'll take a look at an alternative method for finding the integral of a product, and it's called the tabular method. And we'll take a look at those exact two same problems. So the first problem we integrated by using integration by parts was 5x times the sine of x dx, and this is the tabular method. So once again, we must take one factor to differentiate, and we must take another factor to integrate. So the factor that we choose to differentiate, we must be able to differentiate to 0. So we chose 5x as u, and we chose sine x as the factor to integrate. So I'll take 5x and I'll differentiate that to 0. So the derivative of 5x is 5. The derivative of 5 is 0. You must be able to differentiate to 0 in order to use this method. Next, I'll integrate. The integral for sine x is negative cosine x. The integral of negative cosine x is negative sine x. Now I'll simply draw diagonals, and I'll alternate signs, always starting with the positive sign. And thus we have our integral. So we have negative 5x cosine x plus 5 sine x plus c. Now we'll take a look at that second example using the tabular method. So we were asked to integrate x squared times e to the 2x. So once again, we must choose one factor to differentiate and another factor to integrate. So the factor that you choose to differentiate, you must be able to find its derivative to 0. So we chose x squared, and we chose to integrate e to the 2x. So I'll differentiate x squared to 0. So the derivative for x squared is 2x. The derivative for 2x is 2. And the derivative for 2 is 0. Next, we'll integrate e to the 2x. The integral of e to the 2x is 1/2 e to the 2x. The integral of 1/2 e to the 2x is 1/4 e to the 2x. And once we take its integral again, we have 1/8 e to the 2x. Next, we'll draw our diagonals. We'll alternate signs, always starting with the positive, and thus we have our integral. So we have 1/2 x squared e to the 2x minus 1/2 x e to the 2x plus 1/4 e to the 2x plus the arbitrary constant. Now we'll take a look at a couple of more examples. And on these examples, we're forced to use the integration by parts for the simple fact that we cannot differentiate any factor to 0. So here we're asked to integrate the natural log of x dx. So in this example, I'll set u equal to the natural log of x. I'll set dv equal to dx. I'll differentiate our u substitution equation. So on the left hand side, we have du over dx. The derivative for the natural log of x is 1 over x. I'll solve for du, so I'll multiply both sides by dx. And I have du is equal to 1 over x dx. Next, we'll integrate the dv substitution equation. So we have v equal to x. And now we'll substitute into integration by parts. So integration by parts says that that's equal to u times v minus the integral of v du. So once we integrate dx, we have x. So our final integral is x times the natural log of x minus x plus c. So let's take a look at our last example. And here we're asked to integrate x squared times the natural log of 6x dx. So we'll choose u as the natural log of 6x and dv as x squared dx. So once we differentiate our u substitution equation, we have du is equal to 1 over x dx. And once we integrate our dv substitution equation, we have v is equal to 1/3 x cubed. And now we'll substitute into the integration by parts formula. So we have u times v. So that's 1/3 x cubed times the natural log of 6x minus the integral of v du. So that's 1/3 x squared dx. I'll pull 1/3 in front of the integral operator. And I'll integrate x cubed. And I'll integrate x squared, which gives us 1/3 x cubed ln 6x minus 1/9 x cubed plus c. Thanks for watching.